This is the MathCounts homework for the 23rd of September. First, I want you to make Pascal's triangle up to the 7th row. This will be super helpful for the rest of these problems. So you're gonna have to write really small. Be careful here. Remember that there always starts with a 1, and we do 1, 1, and then you always have sides of 1, but now that I have two numbers, these two numbers add together. 1 plus 1 is 2, and then again we have 1s out here, and then I add 1 plus 2 to get 3. I add 2 plus 1 to get 3, and then I keep going down. I say, okay, I still have 1s on this side. Then I add 1 plus 3 to get 4. I add 3 plus 3 to get 6, and I add 3 plus 1 to get 4. And then hopefully you're noticing, just like we saw in class, that there's this natural symmetry over the center where we have duplicates on either side, duplicates on either side. Sometimes if you're in the center, then you have just a single number by itself. But we're going to continue doing this. We have 1s on the side, and I do 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. I'm going to use the symmetry of the table. If I know that there's 10, 10, this next number must also be a 5, just using symmetry. I don't have to do any more addition. And then again, I'm going to have 1s on the side, and then I have 6. And then I add again, 5 and 10 make 15. 10 and 10 make 20, and I notice I've hit the halfway point. This is kind of the center of my triangle. Therefore, this next number over here is going to be 15 and then 6. 15 and then 6, and I only have to go up through the 7th row, so this is going to be our last row. I have 1 on the outside, and then I have addition. 1 plus 6 is 7, and then 6 plus 15 is 21. 15 and 20, these two numbers make 35. And I have another 20 and 15, which makes 35, and I use symmetry for the rest of the table. 21 and 7, 21 and 7. So we didn't really get much time to talk about this in class, but now it's a video. I can kind of record a longer question, or a longer answer, a longer response, if you will. Did you see any of the patterns other than the symmetry that we saw earlier? Well, I see that if I look down here, I see 1, 2, 3, 4, 5, 6, 7. And again, because of the symmetry, you could go this way as well. Usually I'm going to start up here and then go this direction. Some other interesting symmetry are these numbers right here. I don't know if you have ever recognized these numbers. These are known as the triangular numbers. If I make a triangle, there's a single triangle of 1. If I make a triangle, oh, there's 3 numbers. And if I do another triangle, there's a total of 6 dots. If I do more dots, oh, that's bowling, that's 10 pins. These are all the triangle numbers. There's other cool facts too, like if I add up the numbers in each row, you don't have to do this. This is just me going above and beyond here. So this is adding up to 1, adding up to 2, and then I can say 1 plus 2 is 3, plus 1 is 4. And then if I say 1 plus 3 is 4, 3 plus 1 is 4, 4 and 4 make 8. And you might see this pattern in the table. It keeps multiplying by 2. And indeed, if we multiply by 2 again, we get 16, which makes sense because I have 5 and 5, which makes 10. Plus the 6 to get 16, and this pattern continues. And one of the favorite things that you should do if you ever go to higher learning, university, Saracosa, whatever it is, and you're talking to a mathematician that's a real mathematician, a good question to ask them that will really get them talking is, in Pascal's triangle, what's your favorite pattern? Because there's a lot of patterns that even Mr. Sindel doesn't know. I've asked this question a lot to my professors because it's a fun question. And there's some really cool ones in here that even I haven't seen. So this is going to be useful later. We'll talk about Pascal's triangle. Just for today, we're doing combinatorics. We're doing choose. We're not even doing permute. So we're doing the unique number of possibilities. So if I have 6 paints to choose from, and we're picking 3 of those, the trick that we learn in class is we come down to the number of total possibilities that I have, 6 possible paints, which means I'm talking about this row right here because it starts with a 6 for the second number. And then I'm going to go to the third object, assuming I start with 0. So for example, I'm going to say, okay, here it is. If I pick 0, if I pick 1, if I pick 2, if I pick 3, if I pick 4, if I pick 5, and if I pick all 6 of them, that's how many possibilities there are. So if I'm picking 3 of them is this number, and if I let go of it, the answer is 20. There are 20 unique colors. 20. If you want to know the technical mathematical formula for this, you can say that it's this is technically the same thing as, and I don't know why I switched to blue here. I want to switch back to red. The answer is 20. Well, that's not red. The answer is 20, and it comes from this phrase where you say you have 6 things and you choose 3 of them. That's the official formula. And sometimes mathematicians write the formula like 6 and 3, and we just kind of leave it as almost as if a fraction. We put parentheses inside. That's another way of saying 6, choose 3. And there's yet another way of doing that. You can, and this is like going really above and beyond here. You can do 6, factorial all over 3 factorial, and then 6 minus 3 factorial. And we barely talked about that factorial in class on our last lesson, but that is another way of getting the same answer. This will evaluate as 20, I believe, unless I've done something incorrect here. All right. And then we're just gonna now, I've done the long explanation. Let's just run through the rest of these, right? So 5 pizza toppings, meaning we're talking about row 5, and I'm picking 3 of them. So I'm gonna pick 0, 1, 2, 3. Therefore, I'm picking 10. The correct answer here is 10. All right, we're looking at 7 students and making 5 unique teams. And I should say also, in each of these questions, 2 through 8, order does not matter. If I choose pink and then blue and then blue and then pink and then mix them together, it's the same color. For pizza toppings, I guess order kind of matters, but if I have pepperoni and pineapple, it's the same as pineapple and pepperoni. Usually all of these, order doesn't matter, and that's why it's called a choose as opposed to a permute. So this triangle trick only works if the order does not matter. When the order does matter, I'll teach you another trick. It's not that hard. Okay, so I'm on row 7, and I'm doing the 5th one. So I go 0, 1, 2, 3, 4, 5. The correct answer is 5, which is 21. All right, so I say 21 here. Flowers, so I'm from 4, I'm picking 2. So from the 4th row, we're picking 2. We're going 0, 1, 2. Therefore, the correct answer is 6. Come down here. Whoa, didn't mean to do that. Looking at sushi, possible of 7 things on the menu, and I'm going to choose 4. I guess the order doesn't really matter when I'm eating, right? So 7, then choose 4. So I go down here to row 7. I'm going to go to the 4th one. So it's going to be 0, 1, 2, 3, 4. So it's going to be 35 in this case. 35 unique dinners there, Mr. Snell. So many. Oh, Mammoth Fun Shop. We got 2 games to pick out of the 6. It doesn't matter which games that order those. So it's going to be 6, choose 2. So I go down to the 6th row. I'm going to choose the second one, 0, 1, 2. And there it is. It's going to be 15 for this one. 15. And then finally, it's going to be 6, choose 3 for toppings at a sandwich. So if I come down here to row 6 and I choose the 3rd one, it's going to be 0, 1, 2, 3, which is 20. I think that was a repeat of this one, wasn't it? That's okay. 20. Well, hopefully you learned something. That concludes this video. Thanks for watching.